Okay, so my alarm went off, so I got cut off. So we're gonna have two videos for lesson one, which is fine. Okay, so here we are. We drew it. We tried to fold it in half, and it didn't line up. Okay, so here's a figure that shows the first few steps to constructing the regular hexagon. So this figure is showing like the first few steps to constructing it. So we're going to use the straight edge and compass moves to finish constructing the regular hexagon. So basically what you do is you set this to these. Okay, so you set your compass to this radius. That's the goal. All right, so we've drawn a circle, right? Basically, here's how they did it. They drew this circle, right, with that same radius, and then they switched it, and they drew the same size circle, but using the endpoint. Okay, so here's how we do it. You get all these intersection points, and what you essentially do is you just keep building circles. Now watch, this is going to go through that first center. At least it should, yep. And it should touch this one, yep. And then you're going to have an intersection point and then finish your circle. Now you go to this intersection point. Draw another circle. Should go through the center, it sure does. That point, sure does. Creates another intersection point right here. Then you put the point right there. Draw another circle. Okay. And you go over to this point. And draw another circle. It's got to be precise though. Can't choose the wrong spot. It goes through the center, goes through the intersection point. Finish your circle. Boom. All right. And there's one last intersection point right there. Which goes again through the center and creates another circle. Now, what you're gonna find, all right, we have the center of the original circle. We've got the end point. We've got an intersection point. We've got another one right there. Another one right there. Another there. Another there. Now, to build that hexagon, you just connect the dots. You're gonna find an interesting phenomenon. There you go. These points make up a regular hexagon, and that's how you do it. Now, if that's not sinking in, just rewind the video and watch it again. So let's answer number 3. How do you know that each of the sides of the shape? So how do you know that that side and that side, that side, that side, that side, and that side? How do you know they're the same length? Show or explain your reasoning. So, you know that these are all the same length because check it out. Isn't that the radius of this circle? Isn't this the radius of this circle? Isn't this the radius of this circle? Remember radius, center to the outer edge? Isn't this the radius of this circle? Isn't this the radius of this circle? The reason why all 6 sides are the same length is because each side is a radius of the same size circle. All of these were created with the compass, which was set to that distance. Okay, that is lesson 1. So let's look at the summary. To construct geometric figures, we use a straight edge and a compass. Straight edge, compass. These tools allow us to create precise drawings. Precision is MP6. We're going to talk about that more. But these precise drawings are ones that someone could copy exactly. So somebody else could copy these, which is really, really important. Like say you build a house and you got to build the same exact house next door. Got to be able to copy things precisely. So MP6 is to attend to precision. All right, let's look at this bullet point. We use the straight edge, again, ruler, to draw a line segment. That's a set of points on a line with 2 endpoints. So all the points that are on a line, and there's 2 endpoints, like A and B. We name a segment by its endpoints. So here is segment AB with endpoints A and B. We use the compass to draw a circle. So the compass, we use this compass to draw this circle, which is a circle's definition is the set of all points. Imagine there are all these points that are the same distance from the center. So if you put a 1,000 points that are this distance away from the center, you would start to resemble a circle. Now I'm trying to do that myself because I'm trying to chalk a 3-point line at my house. I put up a basketball hoop this summer, and every time it rains, the chalk wears away. I'm not able to paint the 3-point line because that's illegal, but I can use removable chalk. And I've got these spray cans. It's kind of cool. But I know that they all have the same distance from basically the bottom of the hoop. And I want to say it's like 20, it's between 20 and 25 feet. I know that. Not exactly sure what it is. I want to say 21 feet is the 3-point line from the bottom of a basketball hoop. So I have to actually do this in real life today. So anyways, this circle has a center of F and a radius of FG. Because remember, the radius is the distance from the center to a point on the outer edge of the circle. So early mathematicians, so we're going way back, like ancient Greece or Rome, you know. So think about like the ancient Greek, Roman mathematicians. Anyway, they noticed that there were certain properties of shapes. So shapes had like certain properties, and they were true no matter how large or small they were. Constructions, think about a construction company that's like building. So constructions are like building stuff. They were used as a way to investigate what has to be true in geometry. So that's it. Unit 1, Lesson 1. Good job. Keep up the hard work.